Okay, so what we're going to talk about here now is one-dimensional motion. It is the first of the big motion topics here in AP Physics 1. The first one will be one-dimensional motion, the second one will be two-dimensional motion. So this is the whole study of kinematics, or part of the study of kinematics. So kinematics is the branch of mechanics concerned with the motion of objects without, or excuse me, get rid of this. That's where we don't need it. Without reference to the forces which cause the motion. So the way mechanics really works is that you got three big ideas: energy, motion, and forces. And then you see how they interlink, but then they also treat themselves separately. And kinematics is when motion is not connected to the other two. So if you look at the prefix KINE, right, that pertains to motion. So that's such thing as like kinetic energy, kinesthetic stretching, kinesiology. That's all study of motion in some way. So understand that mechanics, again, is the branch of physics dealing with the motion and forces producing said motion. And now the goal of kinematics is to develop models that will serve to describe and ultimately explain the motion of real-world objects. And so what we're going to look at are like cars traveling, balls rolling, objects falling, okay? But understand that, yes, physics is a mathematical science, but the description of that physics or kinematics is just as important as being able to solve it. And so what happens is that when you think about kinematics, there's really four questions that you need to answer. Okay? How long does it take, or how long, which is answered by time? How far does an object travel, which actually has two answers, and we'll get into the reasoning behind the two answers here in a second. The first is distance, the second is displacement. Okay, and then the last one, or the last of the major one, because there is that fourth bonus question, is how fast. And much like how far, it actually has two answers, which are speed and velocity. Okay, and the bonus fourth question is, how quick does how fast change? Okay, and that is answered by the term acceleration. So when objects accelerate, they're going to change that question of how fast. Okay, now when you're talking about motion, it is important to establish a reference frame. So that's just where everything gets measured from, or that's really what determines what's moving and not moving. So one of the, if I'm in a still reference frame, anything that comes into it is moving. If I'm in a moving reference frame, anything that comes into mine, that is moving, even though it just seems kind of strange how that will work out. So this helps set the observer and how motion is related to the observer. So what we say is that motion is relative. So there'll be problems that are called relative velocity problems or relative acceleration problems. And so we're just talking about how they're related to each other. Now, here's just an example. So if I'm going to toss a ball up on a train, and this is what it looks like in the different frames of reference. So the first frame of reference is the observer on the train. So here's my train, right? And we're going to say that the motion is going to be to the right. If I'm that observer on the train and I toss a ball up, I'm just going to see that ball go up to its maximum height and come back down. Now, these should be on top of each other, but again, I just want to show you how they're going to be different. So this is the downward travel, and here on the left-hand side is the upward travel. Now, if we take that same scenario, and now our observer, okay, our observer is now outside of the train. Okay, so here's our train again. That the train is going to the right. Now, what they see, right? Here's our person in the train tossing the ball up. What the observer on the outside is going to see, it's kind of this parabolic shape, is because in addition to the up and down motion of the ball in the train, they're going to see the left and right motion as well. So that's the reason why they see a parabolic shape.